Alright, so here's a chain rule, the official one. Chain rule comes from a composition of functions. This is how you guys just saw it on the warm-up, but this is another way to write it right here. The function that's closest to the x goes inside the other function, so that's how you write it. I don't know if you guys remember that. But I don't know. I don't really think of it as two separate functions all the time, but I see the value in it. I think it can really help. So let's take a look at this first one right here. Oops. So for this first one, let's pretend, okay, we're going to look for the f function and we're going to look for the g function. Now in our formula right here, the g function is the inside function, the f is the outside function. So what would be our outside function and what would be our inside function for this one? The inside is the x to the third power. The outside is going to be your cosine x. Okay, so we got our inside function and our outside function. So when you take the derivative of these, you take the derivative of the outside function and then multiply that to the derivative of the inside function. But the inside function kind of gets written twice. So here, let's check it out. So this is y prime. So for y prime, we're going to take the derivative of the outside function first. So our outside function is cosine. Derivative of that is negative sine, and then whatever is inside of it. And so we have x to the third power inside, so that just stays there. You haven't done anything to the inside yet. Then you're going to multiply it times the derivative of the inside function, which would be this guy right here. So we just got to drop that 3, and then subtract 1 from the 3. So we have x to the second power. If it was multiple choice, it probably would be written like this. The 3x squared would be in the front with the negative, and then we'd have sine x to the third. Okay, that's your answer. That's the chain rule. Okay, so for this first one right here, what's the inside function? What's the outside function? I don't know. I think that helps some people. You don't always need this though. So let's say outside function, inside function. No, you don't have to do this. I just think identifying it when you're a noob at this really helps. So, what's the inside function? I think that one's easier to identify. The inside function is x to the fourth, good, plus 1. And then our outside function is just the square root of x. Okay, so derivative of the outside function first. Now, whenever you have radicals and you got to do derivatives, it's easier if they're in exponential form. So we can rewrite this like with y, and then we have x to the fourth plus 1 raised to the 1/2 power. So really, I guess we just write it a different way. Our outside function is x to the 1/2 power. So we got to do the derivative of the outside function first. So in this case, our outside function is just this power right here. So we're going to drop him in front. So our y prime would be 1/2 in the front of this guy, the inside function right there. And then we got to take 1 away from the 1/2, which would be negative 1/2. Okay, and then we have to multiply it times the derivative of the inside function, drop the 4, have x to the third. The derivative of a constant is nothing, so it goes away. Alright, so we can simplify this a little bit. Let's see, this would be 1/2 times 4 would be 2x to the third power. And then we have that multiplying to x to the fourth plus 1. That's being raised to negative 1/2. Now because of that negative 1/2, we could rewrite this with a fraction. So we could write this as 2x to the third over x to the fourth plus 1. And now that's a positive 1/2. And then we can rewrite this without the 1/2 power. We can rewrite this instead with the square root. So that's your final answer right there. Now, all those other steps right here, like this is correct, and what I had before with the 1/2 power is correct. You just have to know how to manipulate it, because you guys will be taking a multiple choice portion for demonstrating your understanding of this, and you got to know how to find your answer if your answer doesn't match one of them. Alright, let's do this tangent one. Okay, so our first trig one with the chain rule. Our outside function. What's our outside function for this one? Yep, tangent. So tangent x, and then the inside is going to be x over x plus 1. We got a polynomial right here on the bottom of this fraction, so that means we're going to have to use the quotient rule when taking the derivative of it. So what is that? What is the derivative of tangent? Secant squared. So we have y prime. Actually, it's not using the y prime notation. It's using dy over dx. So instead of writing y prime, we go dy over dx. That's the derivative of function y with respect to x. Okay, so now we have, what was it, secant squared, and then you write whatever's inside. So we have x divided by x plus 1. And we have to multiply that times the derivative of the inside. The derivative of the inside is going to be the quotient rule. So I'm going to go ahead and square the bottom because, let's just get that one out of the way. And then the top, we have to do the, what was it, Lodi high minus Heidi low?
Wait. When you say Lodi high, is it
Low derivative of the high minus Heidi low. So it's the high times the derivative of the bottom.
When you say Lodi high, that's it.
I know.
Low derivative and then the high.
No. It goes d, then it tells you what you're taking the derivative of after that. Okay, so anyways, the derivative of the top is just 1, and then you multiply it by the bottom. The derivative of the bottom is just 1, and then you multiply it times the top. So, actually, that wasn't that bad, huh? So we have, let's rewrite this, secant squared x over x plus 1 times, and we can simplify this. Let's see, this 1 doesn't do anything, this 1 doesn't do anything. Now I just have a negative x right here, and there's a so what happens when you have the positive and negative x? Yeah, they go away. They cancel each other out. I just have a 1 up top, so it's going to be 1 over x plus 1 squared. Just a little simplification here. It doesn't matter that much. I believe you guys don't have problems with this. X plus 1 all over x plus 1 squared. Alright. Cool. That was good.